Welcome dear students. In this video we are going to learn about LCM, that is the least common multiple. We know that a multiple of a number is obtained by multiplying the number by any natural number. Thus 3, 6, 9, 12, 15, etc. are multiples of 3. Because 3 1 the 3, 3 2 the 6, 3 3 the 9, 3 4 the 12, 3 5 the 15. So 3 has been multiplied by natural numbers 1, 2, 3, 4 and 5, etc. They are all multiples of 3. Similarly 8, 16, 24, 32, 40, etc. are multiples of 8. The least common multiple is used when two or more numbers are involved. LCM is the least or the smallest of the common multiples of the given two or more numbers. Thus, while HCF of numbers, say x, y and z, is the greatest number that divides x, y and z, LCM is the smallest number that is divisible by x, y and z. Let's understand LCM by finding LCM of two numbers 8 and 12. So we list the multiples of two numbers. We list the multiples of 8. 8 1 the 8, 8 2 the 16, 8 3 the 24, 8 4 the 32, 8 5 the 40, like this. And we know that multiples of any number can go on endlessly. Similarly, we write the table, which indeed is nothing but the multiples of that number. So we write multiples of 12, 12 1 the 12, 12 2 the 24, 12 3 the 36, 12 4 the 48, like this. And we then locate and identify the common multiples. They have been highlighted in red color. So 72 is here, 72 is here. 48 is here, 48 is here. 24 is here, 24 is here. So we see that these multiples are common. 24 is common, 48 is common, 72 is common. But as per the definition, we have to look for the smallest or the least multiple, which is 24. Thus the LCM of 8 and 12 is 24. Now let's take one more example of three numbers, 3, 6 and 9. So as before, we list the multiples of 3, or we write the table of 3, then we write the table of 6, and then we write the table of 9, and look for the multiples which occur in all the numbers. 36 occurs here, 36 is here, 36 is here. 18 is here, 18 is here, 18 is here. Now we see that 18 is the smallest multiple. So clearly the LCM of 3, 6 and 9 is 18. Dear students, this is the most fundamental method of finding the LCM. But this method is suitable only when the numbers are small and are close to each other. Practically, we find LCM by prime factorization method or the long division or the grid method. So let us try to learn to find LCM by those methods. LCM by prime factorization. LCM is given by the product of the greatest power of each prime factor involved in the numbers. I suggest to the students to watch the video titled HCF, which was uploaded just before this, and compare the two definitions with each other. In HCF, we say HCF is given by the product of the least power of each common prime factor, and LCM is given by the product of the greatest power of each prime factor. There is no word common. We have to choose the each prime factor, and again among those prime factors we have to choose the greatest power. So this difference of expression of these words must be very clearly understood, and I suggest to the students that write down these definitions of HCM, HCF and LCM side by side and memorize them and understand them very clearly. Further, what is prime factorization and how to do it, has been covered separately in video titled Prime Factorizations. So students who are not familiar with prime factorization should watch that video first before proceeding further. So we find LCM of numbers 18, 30 and 42 by prime factorization. So we have done this prime factorization by the grid method or the division method, and the prime factorization of 18 is 2 into 3 raised to power 2. Prime factorization of 30 is 2 into 3 into 5, and prime factorization of 42 is 2 into 3 into 7. Now we have to write down all the factors. So 2, 3, 5 is here and 7 is here. So first we write all the factors 2, 3, 5 and 7. Then we look for 2 highest power. So 2, 1 power, power 1, power 1. So 2 has appeared with the highest power as 1. Then we look for 3. 3 has appeared here 2, here 1, here 1. So we look for the greatest power of 3. Okay, so we put 2 here. Then we look for 5. It appears only 1 with power 1. 7 also appears only once with power 1. So we multiply these together and we get 630, which is the LCM of 18, 30 and 42. Let's consider one more example. LCM of 6, 36 and 54. So prime factorization of 6 is 2 raised to power 1 into 3 raised to power 1. 36 prime factorization is 2 square into 3 square. 54 prime factorization is 2 into 3 raised to power 3. Now LCM of 6, 36, 54 will be all the factors 2, 3. Yes, we have got only 2 factors, and the highest power of 2 appears here. Okay, so we put highest power 2 here, and the highest power of 3 appears here. So we put the highest power of 3 here. So 2 square into 3 square is equal to 108, and that is the LCM of 6, 36 and 54. Now we do the LCM by grid method or division method, and we have chosen the numbers 35, 45 and 180. So write the numbers horizontally like this, separated by commas and little space. Make a grid like this, a vertical line and the horizontal lines. Now in this method, you start with the smallest prime number. Okay, but when you choose that prime number, you see that it should divide at least two numbers among that group of numbers whose LCM we are going to find out. There is no harm if you start dividing only the one divisible number, but it will be just a wastage of time. Now I see that 2 divides only 180, but it does not divide 35 and 45. So I try 3, and I see that 3 divides 45 as well as 180. So I start with 3. 35 remains like this because it does not divide 35. So 45 divided by 3, 15. 180 divided by 3, 60. Okay. I again see that 15 and 60 are divisible by 3. So I again divide 3. 35 remains like this. 3 5 the 15, and 3 into 20 is 60. Now I see that 3 does not divide anymore now. After 3 is 5. I see 5 divides 35 as well as 20. So 5 7 the 35, 5 1 the 5, 5 4 the 20. Yes, 5 has divided all 3. Now I see that there is no other prime number which will divide at least two of these numbers. 7 and 4 are co-prime. So I could write 7 here, divide by 7 and 1 put here, then again divide by 4, put 1 here. There is no point in doing that. There is no point in occupying the space further down and wasting time, because we cannot divide any two numbers simultaneously. So there is no point. We just multiply these numbers with these numbers. So after we have stopped there, I repeat again, keep dividing till you can divide at least two numbers simultaneously. At a point when you cannot divide at least two numbers simultaneously, stop dividing there and then multiply all the divisors, which are here vertically written, with all the quotients received down below. So what is LCM? 3 into 3 into 5 into 7 into 1 into 4. So 3 into 3 into 5 into 7. 1 is not written because multiplying by 1 it is same thing. So into 4, and the LCM is 1260. Let's do one more example. LCM by grid division method, numbers 24, 55 and 90. Now I see that 2 divides 24 as well as 90. So 12, 55 remains like this, and 45. Now I see that 2 does not divide two numbers. It divides 12, but it does not divide these two. So I see that 3 divides 12 and 45. So I start with 3. 3 for the 12, 55 remains like this, and 3 5 the 15. Now I see that 3 does not divide further. 4 divides only this but not these numbers. But 5 divides these two numbers. So 5, 4 remains like this. 5 1 the 5, 5 1 the 5, 11, 5 3 the 15. Now there is no other number which will divide at least two of these numbers, which will divide the, so there's no need to proceed further. What I do is I multiply all these L-shaped together. So LCM is 2 into 3 into 5 into 4 into 11 into 3 is equal to 3916 is the LCM of these three numbers. It saves a lot of time. You may find little difficulty initially, but once you practice it, you will become expert in this. Now we come to shortcut method for LCM. It will save further few seconds and even minutes. This will be useful to you when you go for your competition exams after your plus 2 or after your graduation. Let's say number 630, 1050 and 1890. As I told you, you divide only when you can divide at least two numbers simultaneously. Further in this step, don't go for the smallest prime number. You can go for the product of two prime numbers which are not very large, but for this you should be familiar with the tables. You should be very good at your tables. Now I see that 0 is here, 0 is here, 0 is here. So I could first divide by 2 and then divide by 5. That would be two operations. So instead of doing that, I straight away divide by 10. So 630 becomes 63, 1050 becomes 105, 1890 becomes 189. Now these are odd numbers. They will not be divisible by 2. So I check their divisibility by 3. So 9, 8, 17 plus 1, 18, divisible by 3 but also divisible by 9. So 5 plus 6, not divisible by 3 but not divisible by 9. 3 plus 6, 9, divisible by 3 but not divisible by 3 but also divisible by 9. So I have two numbers 63 and 189 which are divisible by 9. So instead of dividing by 3 first and then 3 again, I straight away divide by 9. So 9 7 the 63, 105 and 9 into 21 is 189. Now I have three numbers 7, 105 and 21 which are divisible by 7. So 7 1 the 7, 7 into 15 is 105 and 7 into 3 is 21. Now I see that 15 and 3 are divisible by 3. So 3, 1, 3, 5 and 1. So in this method, we do the other way around. You start with the largest number, dividing with the largest number and then reduce the numbers. This sometimes saves lot of time. Now I see that only one number is left 5, so there is no point in going further. So I just multiply these numbers together. So 10 into 9 into 7 into 3 into 5 is equal to 9450 and that is the LCM. Now one more important fact, LCM of co-prime numbers. So we have chosen two composite numbers. Two prime numbers are in any case always co-prime with respect to each other. So we have chosen 28 composite and 33 composite. Now we see that there is no common divisor. There is no number which divides them both. So there is no point in proceeding with the division process. So as I said, when you cannot divide two numbers simultaneously, you just multiply them. So LCM is equal to 28 into 33 is equal to 924. Now what does this mean? This means that if two numbers are co-prime, then their LCM is given by their product. In HCF, we have studied that the HCF of two co-prime numbers is always 1. And in LCM, we say that the LCM of two co-prime numbers is always given by their product. So, dear students, with this we come to the end of this video. I hope this video was helpful to you in understanding what is LCM, its definition, and the different methods of finding the LCM. For more videos related to education, math concepts, solutions of NCERT math book 8th, 9th and 10th class, and other videos on puzzles and Gurbani, do subscribe to this channel. And do remember to like and share the videos. Thank you very much. God bless you all. Thank you very much again. ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਬਹੁਤ ਬਹੁਤ ਧੰਨਵਾਦ। ਰੱਬ ਰਾਖਾ।